What we're going to begin today is the branch of math called trigonometry. Um, Trigonometry is thousands of years old, developed um, by first the Egyptians to some extent, but really it was the Greeks that fully developed the science of trigonometry. Um, and what it deals with is um, finding uh, angle measure and side lengths using ratios, and it's dealing specifically with a right triangle. And what it means is, or what we're doing is, it's a branch of math that deals with the ratios between sides of a right triangle with regard to the, or with reference to the acute angles of the right triangle. If you take a look in the triangle here below, and oh, a little screwy there, see that's a right angle. A is the length of the leg, and the way we do it in math is um, the sides are opposite the angle. So here, should go back to my blue. There. If this is angle A, the side opposite it is side A. If this is angle C, the side opposite is angle C, etc. There's B. We label the angles with uppercase letters and the sides with lowercase letters. Okay, so as it says up above, just going to go up a little bit. In triangle ABC below, A is the length of the leg opposite angle A. B is the length of the leg opposite angle B. And C is the length of the hypotenuse. Okay, now the hypotenuse of a right triangle, a lot of people fall into the trap of saying it's the longest side, which is true, but unless you have all of the side lengths, you really don't know that. So the foolproof way of knowing that a side is the hypotenuse is it's the side opposite the right angle. Okay? Depending upon the acute angle being used, the leg that is attached to that angle and not the hypotenuse is called the adjacent side. So in other words, if we're at angle B, right, this angle right here, side C is the hypotenuse. That's the only word we use to describe that side. Side A is adjacent, word adjacent meaning next to. Okay? Now, you are given, or we're given a sheet in class that has these trigonometric ratios. Now, what the concept is very, very straightforward. What the Egyptians and Greeks figured out was that if you took a right triangle and you figured out the measure of the sides of that right triangle, that no matter how big or how small you made the right triangle, the sides would still be in the same proportion as long as the angle measures were the same. So in other words, we all know that a right triangle or any triangle measures 180 degrees. So what they found out is that if, for example, this angle was 40 degrees and this angle was 50, that if we blew up the triangle, and you remember this would be called a dilation, if we doubled the size, okay, so let's say this measured 2 and this measured 3, okay, if we doubled the size, everything would stay in proportion. Now, why is that important? Because what that allows you to do is to extrapolate and figure out side measures or angle measures as long as you have certain information. Okay? Now, taking a look at the triangle up here above, the ratios in the right triangle are sine, cosine, and tangent. You see them on your sheet. Sine and the sine of A, all right? So I'm at angle A, is the ratio of the opposite side, which measures 4, to the hypotenuse, which measures 5. Cosine of A, adjacent to hypotenuse, and then tangent, opposite to adjacent. And then on the flip side, I'm going to have to move a little quick because my battery is dying. Sine of B, cosine of B, and tangent of B. Now, going to the next page, what we're going to do here is, again, we're going to do the same thing of finding these measures. This is 8/10, which is 4/5, 6/10, which is 3/5, and then 8/6, which is 4/3, 6/10, 3/5. I'll just cut to the chase, 4/5, and 3/4. Now, when using your calculator has to be in degree mode. So I want to find the sine of an angle that measures 38 degrees. How do I check that I'm in degree mode? I go to my mode button. My cursor is not over degrees, so I go down to the third. I move it over to degrees. I hit enter. So now I want to find the sine of 38 degrees. I hit sine 38, and it's going to give me a decimal. So that's quite simply how we do when we're trying to find the ratio. If I give you the ratio and I want to find the angle measure, like I want to find what the angle is whose ratio is 0.7547, I hit second first, cosine 0.7547, hit enter, and get that angle measure. So I'm going to just fill in this data because I am losing my power here, 0.6157. So this way when you're practicing, you know you've got the right numbers. And then this is 41 degrees, 78 degrees, and 54 degrees. Right. So that's the basics of trigonometry.